Hello, SAT students. This is Mrs. Scott, and I am here for your lesson number 14. And this lesson is about geometry, similarity. So really, when we talk about similarity, we're really talking about proportions. So things that are proportionally related, making proportions, solving equations with proportions, and of course some geometry is all involved in this lesson. Here's a tip for you. Most of the similarity problems, like I just said, can be set up using a proportion, cross multiplying. We are always going to be looking for similar triangles. And just when in doubt, try to set up a proportion, okay? Now, this first problem is simply algebra, just reminding us about cross multiplying. So here, this is a proportion when I have a ratio equal to a ratio, and in order to solve a proportion, I can use the property that says if I cross multiply, I get equivalent statements. So you can see I kind of started the problem. When I cross multiply and I have a binomial, make sure you put that binomial in parentheses and distribute or FOIL when we multiply a binomial times a number or by another binomial. So in this case, 2 times 1 is 2. That's where I got this from. And then I have a binomial times a binomial, x minus 3 times x minus 4, which I have to FOIL. So I get x squared minus 4x minus 3x, which combines to minus 7x plus 12 equals 2. Now let's backtrack for a second. This question is saying this should have 2 solutions. And what is the product of the solutions? So this is something the SAT does a lot. They not only want you to solve something, but they want you to do something interesting with the solutions. So just always be careful and make sure you understand what the question's asking. So to solve a quadratic, I need to get everything on one side and then factor. So this factors to x, let's see, minus 5 and x minus 2, right? Because negative 5 times negative 2 will give me a positive 10, and negative 5 plus negative 2 gives me a negative 7. So that gives me 2 solutions, 5 and 2. And again, it's asking me for the product. So 5 times 2 is 10. So the answer is 10, and just make sure you bubble in or grid in your question correctly. All right, let's go to number 2. So it says, of the 126 students who applied for a full scholarship to Kent College, 9 were successful. What is the ratio of students receiving a scholarship to those who did not? Well, first we have to figure out how many did not receive the scholarship. Well, if 9 did, then let's take the total number of students who applied, 126, and subtract out the 9. I'm left with 117 kids that did not receive the scholarship. So if you got the scholarship, you were one of 9, right? And then 117 did not receive. Now this is asking for a ratio. Ratios are, it's really important to understand the order. So it's read the way that you write the answer the way that you read it. So it says ratio of the students receiving to those who are not. First of all, I like to write it as a fraction, okay? So students who got it go on top because that's what came first, and who did not go on the bottom. Let's reduce this. This reduces, both 9 and 117 are divisible by 9, so you get 1 over 13. And then to write that as a ratio, we're gonna write 1 to 13. All right, so now some practice problems. So this one says a dessert recipe requires P tablespoons of sugar and Q cups of flour. If Peter wants to make a larger batch using P plus 2 tablespoons of sugar, then how many cups of flour will he need to keep everything proportional? Well, the question is how many cups of flour. So I always like to make that in my unknown, my X. There's a lot of unknowns here, but look at my answer choices. There's going to be 2 variables in my answer choices anyway. So let's make a ratio here, a proportion. So P tablespoons over Q cups of flour. Well, now in my new situation, I'm gonna have P plus 2 for the sugar, and this is what I don't know. So how many cups of sugar? So let's cross multiply. We get P times X equals Q times P plus 2. And we're just going to get the x by itself because that's what I'm looking for. That's the unknown. So x equals Q times P plus 2 all over P. And that answer choice is D. They wrote it in a different order, but that's okay. Now, the next problem, this one I'm going to solve a little bit differently. So if you've taken Algebra 2, then you might remember learning about direct variation. So when things are directly proportional, that's implying direct variation. So I'm actually going to use that to solve this problem. I think it's easier that way, but you could also make a proportion. So there's really more than one way to solve this, but let me explain my strategy here. If you remember direct variation, then this is what, the one thing that's kind of tricky is you have to find this K value. So this says a piece of lumber is directly proportional to its length. So in Algebra 2, you might learn the cost, so that's where I put the C, is directly proportional. What you want to do is put this constant of variation, so it's a K, and we're going to actually find that value, and then times its length. So when I have something directly proportional, that means that the two are the K value and then the length or whatever is directly proportional. They're being multiplied. All right, so then it gives me information. It says 16 feet of lumber costs $12. So the cost is $12. And then I'm going to keep the K there, and I'm going to plug in for L. And instead of plugging in 16, I'm actually going to plug in 16 over 3. And the reason I'm doing that is because they want the answer in yards instead of in feet. So I converted 16 feet to yards by just dividing 16 by 3. And I plugged that in instead of the feet. So now I'm going to solve for K. To solve for K, I'm going to multiply both sides by the reciprocal of 16 over 3. So 36 over 16 equals K. Let's reduce that. Both of these are divisible by 4, so that's 9 over 4. So the cost is equal to 9 over 4 times the lumber in yards. So that is answer choice D. Now, I also could have made a proportion, but it would have been challenging because of the change in units. So since I went from feet to yards, I would have had to set up a proportion that looks like this. 12 over 16 thirds equals X over C. And I just thought that that was a lot of variables, the X being the number of, or the lumber amount, and then the C being the cost. So in my equation, instead of an X, I had an L, but this is how you would have set up the proportion to get the right answer. So that one's a tough one. We are going to move on to number 3. Hi. Making a video. Sorry, guys. So for number 3, we are going to do, this is a classic geometry problem. So a man is 5 feet 8 inches, and he casts a shadow of 8 feet. What is the height in feet of a pole that casts a shadow of 96 feet? Here's the deal. So these shadow problems, the sun is beaming down at the same angle at the same time, so we can assume that the triangles made are going to be similar. So I converted 5 feet 8 inches to just inches, which is 68 inches. And that casts a shadow of 8 feet. And then we are looking for, okay, but I did forget one part of this. So then we are looking for the height of the pole, but it says, that's the problem. I knew I had a problem here. Here's the problem. This right here is inches, and this is feet. I also want to convert the 8 feet to inches. Okay, so 8 times 12 is 96. And then let's also convert this to inches. So 96 feet is going to be 1,152. Now, I could have done the other way. I could have kept everything in feet. This just would have been a decimal. So let's first solve. Okay, so it's going to be similar triangles. So the corresponding sides are the 68 and the x. So 68 over x equals 96 over 1,152. Cross multiply. I'll do the work over here. We get 96x equals, when I multiply 68 times 1,152, I get 78,336, and divide both sides by 96, and you get 816 inches, but this is asking for you to convert back to feet. I think it might have been easier to maybe just have everything in feet, including a decimal, but either way, it really doesn't matter, as long as you convert back to feet at some point. So that's where we get that answer of 68. All right, next problem. So this one says, it takes 4 joules of energy to raise the temperature of 1 milliliter of water by 1 degree. How many joules will be needed to raise 3 liters of water by 8 degrees? Whew, okay. So let's make a proportion with joules to milliliters. So 4 joules will warm up 1 milliliter, okay? Now, how many joules will heat up 3 liters, which, by the way, is 3,000 milliliters? The SAT really screws with the units, okay? So they often are gonna give you things in different units, and they might give you a hint of like a conversion like they did in the last problem, 1 foot equals 12 inches. But there is a lot of converting units. Keep that in mind as you guys take it. Just be really close, pay really close attention to the units. So then, by the way, when I solve this, I get x equals 12,000. 4 times 3,000 is 12,000. But that's for just 1 degree. So we want it to warm up not by 1 degree, but by 8 degrees. So that's why I take this answer and multiply it by 8. And that's where I'm getting this 96,000. All right, next problem. We got 2 more. On a map, a 1/4 inch represents 20 actual miles. How many inches on the map separate 2 towns that are 325 miles apart? So you can see here I set up a proportion. I like to kind of write it out in words so I remember what to put where. The map is 0.25 inches is 20 miles. And then we want to know how many inches would be 325. So I'm going to cross multiply. I get 81.25 equals 20x. Divide both sides by 20. So I get my answer of 4.0625 equals x. You do want to round because I need it to fit into this grid. So 4.06 is the answer, which you can see I wrote here. Just make sure you bubble in, and a decimal is up here, and then 0.6. All right, guys. We have got one more, and this one's a complicated one, so save the best for last. All right, so here's the deal. It says the base of a pyramid. I had to read this like 4 times, so you might come across a problem like this when you are taking the SAT. Sorry. The base of a pyramid has the same area as the base of a cylinder, and the cylinder is twice the height of the pyramid. What is the ratio of the volume of the pyramid to the volume of the cylinder? So, wow. I started by saying, okay, what are those formulas? The volume of a pyramid is 1/3 the area of the base times the height. The volume of a cylinder is pi r squared times the height. Now, pi r squared is the base of the cylinder. And what we know from the problem is that the base of the pyramid has the same area as the base of the cylinder. So I highlighted the base, and the base is pi r squared. And those have to be equal, okay? Now, the other wrench in the game is that the cylinder is twice the height. So if this cylinder, or if this pyramid has a height of 5, then this one needs to have a height of 10. So I put a 2 here because the heights, assuming the heights are equal, we need to double this one. Okay, so with that in mind, I said, okay, now I have to write a ratio. So the volume of the pyramid is 1/3 the area of the base times the height. That one I just kept the same. But the volume of the cylinder, I actually replaced the pi r squared with a b because those are interchangeable. They're equal to each other. So I put a b here, and then I also included the height and the 2 because that height needs to be twice the pyramid's height. So the b's will cancel, the h's will cancel, and I get 1/3 over 2. So that's 1/3 divided by 2. When I divide fractions, I multiply by the reciprocal. So 2 over 1 flips to 1 over 2, and I get 1/6, which is the answer. So that problem was a little crazy. It's one of those that you have to read a couple times and just do one thing at a time. If you didn't know how to start it, maybe just start by writing down the volumes and go from there. All right, you guys, so there's a lot to take in with this lesson. Go back, rewind, and rewatch any problems that were a little bit tough or that I went too fast. And that's all for today. Thanks, guys.